Okay, told you this was going to go quick. Okay, next thing, we can use the definition of conditional probability to find the probability of intersections just by going by multiplying by the denominator. So sometimes a conditional probability is known, and we want the probability of an intersection. So we can use it that way. So from the definition, we have PEF, say. If I multiplied through by, say, F, this would be PE given F, PF. Or I could even do it the other way too. This is PF given E, PE. Okay, so we can just multiply. And should make some sense. The probability that E and F occurs, the probability that E occurs, and then times the probability that F occurs given E occurs. Okay, that's what this tells you. So this is called conditioning on the, this one would be conditioning on F. So this one's conditioning on F. And this one, you condition on E. Okay? So sometimes you want an intersection and you can do it because you know a conditional probability, so it makes it easier. So here's an example. Suppose we have say 4 red marbles and 2 black marbles. Find the probability that if we pick 2 at random, they're both red, say. Okay. All right, so one way, so from the chapter 2 method, unconditional, not using our new conditional probability, we could think of the marbles as being subscripted. Okay, so consider S. S is all selections of 2 where the marbles are distinct, and the way we've been doing that is to subscript them. So, for example, we could have R1, B2, right? Could be, this could be an outcome. Or, I don't want to try to get too fancy. So, or say R, I want to make it clear, R4, R3 is an outcome. Okay, I just look at all the marbles as distinct. And I can do that by just putting subscripts on them. So in this case, S is what size? It's, they're all distinct, right? So it's just 6 choose 2, right? 6. So what's that? 15? It's not that many. Only 15 choices. Okay, yep. Okay, and this is one way to do it. So let's find the probability. So we have 4 red marbles and 2 black marbles. Find the probability if we pick 2 at random, they're both red. So let's call this event, we'll call this event E. Okay. All right, so we could do this then, we've seen. So probability of E using the chapter 2. So if I'm picking 2 out of those 15, if I'm taking one selection of 2, it's the probability of E is the number of events in E over the number of outcomes in E over the number of outcomes in S, because now all choices of 2 are equally likely here, certainly, if it's at random. So this is over 15 down here, right? And how many ways are there to pick 2 and have them both be, what did it say? Both be red. I want to make sure. Yeah, so what's the so from the 4 red ones, we need to pick 2, right? So this is 4, choose 2. So that gives me 6, and so we get 6 over 15, or 2/5. Okay. Another way to do this is we can use conditioning. So from chapter 3, you sort of redefine things. Let Ri equal the event the I selection is red. So I'm going to think of selecting these in order, and BI equal I selection is black. In this case, I could also use the complement. Okay. Then P of E could be expressed like this: P R1, R2. I need R1 to happen and R2 to happen, and then I can use conditional probability. So I'm going to condition on R1, because that's the first event. So this is P R2 given R1 times the probability of R1. So remember, originally there's 6 balls, and 4 are marbles, 4 are red. Now I don't put subscripts here, they mean something else, right? 2 are black and 4 are red. And the probability that the first draw is red is 2/3, that's clear. And now, what's the probability the second draw is red, given that the first draw is red? Well, the first one's gone. So what's the probability the second one is red? It's 3/5, right? And this is equal to 2/5 also. So we get the answer more easily, I think, using this than to make subscripts on the balls and everything. So I think this is added power. Okay, let's see. Should we do another one of these, or are you good? Okay, let's just say part B. What's the probability of F, where F is, we select 1 red and 1 black. Well, using the chapter 2 method, we would have P of F. I want to count, this is F, so I'm thinking of the balls as subscripted over S. S is still 15, right? This is still, so I select 1 red and 1 black from 2. Draw 2, select 1 red and 1 black. S is still, 6, choose 2. And F is now 4, choose 1 times 2, choose 1, right? So on the top I get 8, on the bottom I have 15 still. Okay, maybe that one wasn't as bad, but still, I still find it not as easy. And now chapter 3, we can use conditional probability. Now here, what do I need to do? I need to consider two cases. So this is going to be the sum of two cases. So probability of F, so maybe in a way you think of chapter 2 easier, this, I don't know. Probability of F is equal to the probability, using this idea up here that they are R1, using this, right? Using this for the definition down here. Okay, we have P, F is P R1 B2 union B1 R2, right? Those are the two ways to do it. These are mutually exclusive, so I can sum these up. This is equal to probability R1 B2 plus probability B1 R2. And now I condition on the first one, I think. So I have P B2 given R1, P R1 plus P R2. I still think this is easier in some ways. I mean, B1, P B1. Okay? Once you slow it down and rewind it in your head, you'll see it's easier, I think. So P R1, this is still 2/3. What's P B2 given R1? Well, then I'm here in this box, right? And this should be 2/5. 2/5, not 3/5. So I get 2/5. Plus, what's the probability of B1? Well, that's 1/3. And what's the probability of R2 given B1? Well, there are 4 reds left and only 5 balls, so this is 4/5. So we get 4 plus 4 over 15, 8 over 15. You could tell I'm rushing again, it's at the end of the video. But you can see we have these two ways to do it. I like the power of the second way. I find the sort of understanding the combinations of things a little more elusive, but whatever you want, you now have more tools is the point. All right, stay tuned for the next one.